Now let's go to second part of the generative AI and computer vision. Potential of generative AI. Generative AI has the potential to revolutionize the way businesses operate. It can be used to generate new designs such as the fashion industry or to create new products such as in the pharmaceutical industry. It can also be used to generate new content such as the gaming and entertainment industry. By using generative AI, businesses can save time and money on product development and increase efficiency. Additionally, generative AI can help businesses stay ahead of the competition by allowing them to create unique products and content. Types of generative AI. There are several types of generative AI, including GANs, that is Generative Adversarial Network. GANs are a type of neural network that consists of two parts, that is generator and discriminator. The generator creates new data while the discriminator evaluates the quality of the data. The two parts work together in a feedback loop to create high quality data that is similar to what a human might produce. Variational autoencoder. VAEs are a type of neural network that are used for data compression and construction. VAEs can also be used for generative tasks by sampling from the learned distribution to generate new data. Recurrent neural network, RNNs. RNNs are a type of neural network that are designed to process sequential data such as text or speech. RNNs can be used for generative tasks by training a network to predict the next character or word in a sequence. Applications of the generative AI. Generative AI has many applications across the wide range of industries, such as art and design. Now, in art and design, generative AI can be used to create a new art and design, such as paintings, sculptures, and furniture. Entertainment. Generative AI can be used to create new music, movies, and video games. E-commerce. Generative AI can be used to create product descriptions and recommendations for online shopping. Medicine. Generative AI can be used to create new drugs and treatment plans based on patient data. How it differs from traditional AI? The generative AI differs from the traditional AI in several ways. Traditional AI focuses on analyzing and processing existing data, while generative AI focuses on creating new data. Traditional AI is typically used for tasks such as classification, regression, clustering, while generative AI is used for tasks such as image and text generation. Generative AI also requires significantly more computing power and data than traditional AI due to the complex algorithm and models involved in creating new data. Deep learning and generative AI. Deep learning is a subset of machine learning that involves training neural network with multiple layers to recognize patterns in data. Generative AI can also be achieved using deep learning techniques. In particular, deep learning models such as convolution neural network and recurrent neural network have been used in generative AI applications such as image and text generation. Advantages and disadvantages of deep learning. Deep learning has several advantages over traditional machine learning methods, including its ability to handle large amounts of data, its ability to learn hierarchical representation, and its ability to learn from the unstructured data. However, deep learning also has some disadvantages, including the high computational requirements, its reliance on large amounts of labeled data, and its tendency to overfit on different data or on training data. Computational requirements. The issue with high computational requirement is that it requires more computing power and data than traditional AI to process the complex algorithms and models needed for generative AI. This means that it is more expensive and time consuming to build and run deep learning applications, which can be a barrier for some organizations. High computation requirement also limits the use of deep learning in environments with limited resources such as mobile devices or edge computing systems. In these environments, streamlined algorithms may need to be used in order to reduce computational complexity. Ultimately, high computation requirements mean that not all organizations have access to these powerful tools due to hardware or software limitations. Cloud to the rescue. Many cloud providers offer machine learning services that allow you to quickly and easily set up a deep learning model with minimum effort. For example, Amazon Web Services offers Amazon SageMaker, a fully managed service for training and deploying ML method models, which includes support for deep learning. Azure also offers support for deep learning with the Azure Machine Learning Service. There are also a number of open source solutions such as TensorFlow and PyTorch that can be used to create and deploy deep learning models in the cloud. Overfitting risk. Overfitting occurs when a model has been trained too well on training data, resulting in poor performance on unseen test data. The result is a model that performs well on the specific dataset it was trained on, but does not generalize to other datasets or tasks. This can lead to inaccurate predictions and results. In order to avoid overfitting, it is important to use techniques such as regularization and cross-validation. What are generative adversarial network or GAN in deep learning? Generative adversarial networks can be used in conjunction with deep learning techniques to create realistic images and other types of data. GANs can generate new data that is indistinguishable from real data, making them useful for applications such as image generation and video synthesis. Vendors and open source solutions such as Stable Diffusion, DALL-E, or Generative Pre-trained Transformer, that is GPT, are available to enable GANs. GANs also be used to augment existing datasets, making them more diverse and reducing the need for additional labeled data. However, GANs can be difficult to train and may produce unrealistic data if not properly optimized. How GANs work? Generative adversarial network are a type of neural network that consists of two parts, that is, a generator and a discriminator. The generator creates new data while the discriminator evaluates the quality of the data. The two parts work together in a feedback loop to create high quality data that is similar to what a human might produce. The generator starts by creating random noise, which is used as input. The generator then generates new data based on this noise. This discriminator evaluates the quality of the generated data and provides feedback to the generator. The generator then adjusts this parameter based on the feedback from the discriminator, and the process is repeated until the generated data is high quality. Applications of GANs. GANs have many applications across a wide range of industries, such as art and design. GANs can be used to create new art and design, such as paintings, sculptures, and furniture. Entertainment. GANs can be used to create new music, movies, and video games. Computer vision. GANs can be used for tasks such as image and video generation, style transfer, and super resolution. Medical imaging. GANs can be used to tasks such as image segmentation and disease diagnosis. Benefits and risks of GAN. GANs have several benefits, including their ability to create high quality data that is similar to what a human might produce. GANs can also be used for a wide range of applications, from art and design to medicine and science. Additionally, GANs have the potential to revolutionize industries such as entertainment and e-commerce by creating personalized content for users. However, GANs also pose several risks including their vulnerability to bias and error. GANs are only as good as the data they are trained on, which means that if the data is biased or flawed, the generated output will be as well. Additionally, GANs can be used for malicious purposes such as creating deepfakes or generating fake data to manipulate markets. Natural language processing and generative AI. Natural language processing, that is NLP, is a subfield of artificial intelligence that focuses on enabling computers to understand and interpret human language. NLP techniques can be used in generative AI to create new text and speech data, such as product descriptions, news articles, and synthetic voices from text-to-speech applications. NLP technology in generative AI. NLP technologies from the foundation of many generative AI applications. Some of the core NLP technologies used in generative AI include tokenization, the process of breaking down a text into individual units or tokens, which can be words, punctuation, or other units depending on the application. Tokenization is the first step in many NLP tasks and is used to prepare text for further processing. Part of speech tagging, the process of labeling each word in a text with its corresponding part of speech, such as noun, verb, or adjective, prose and tagging, its use to analyze the grammatical structure of a sentence and is used in many NLP tasks such as sentiment analysis and machine translation. Named entity recognition, NER, the process of identifying named entities in a text such as people, places, and organizations. NER is used in many applications such as search engines and chatbots to extract relevant information from text. Sentiment analysis, the process of determining the sentiment or emotional tone of a text. Sentiment analysis can be used to analyze customer feedback, social media posts, and other types of text data. Thank you.